All right, and you missed another quiz you need to make up. So you would have 2s to begin, 2p, 3s, 3p, 4s, then 3d, then 4p. You would put them in order the way they read, either on the periodic table or with your orbital overlap chart. So if I erase all this crap.
Oh, that's what you meant, Michael.
You could either do this, or you could draw the 1, 2, 3, 4, 5, 6, 7, and do your S, and draw your orbital overlap chart this way. I'm lazy. I don't want to draw that. Okay? So, 2S, 2P, 3S, 3P. What comes after 3P? And then 4P. That's how you get the answer.
Oh, we do it like that.
Yes. That's how you get the answer right there. Okay? That's how you do it. Which one can exist? 4P. What main energy level can hold 18 electrons? The 3. Okay? Because you can have S, P, and D, and they add up to 18. What is the total number of electrons at the second energy level? 8. Because you can add S plus P and get 8. What's the total number of electrons at the fourth energy level at N equals 4? 32. What is the fourth period element with an octet? We haven't used the word octet, but what would you guess an octet means? It's 8, okay? So, which group has 8 electrons? Okay, so which group up here has 8? Did y'all hear Queen? Noble gases. So, 8 electrons is this group right here, okay? So, here's a new word for you if you don't know it. Octet means 8 electrons. So, this is the octet group. And it said fourth period, right? First period, second period, third period, fourth period. So who's going to have an octet in the fourth period? Krypton or Kr. All right, so now it wanted us to write the configuration for phosphorus. So if I write the configuration for phosphorus, all right, now I want you to label some things. What are the inner shell electrons? Okay, that's inner. And that has 10 electrons, right? These would be the outer, and there would be 5 electrons. Do you want anything else? Nope, I think we did everything. All right. So label the inner and the outer. How many are on inner, how many are on outer? So we got them all. All right, number 9, what's the highest occupied energy level in 10? Now, we can do this 2 ways. A lot of people like to write the configuration for 10. All right, Sn has Kr in brackets, 5s2, 4d10, 5p2. What's the highest energy level? That's the way most people choose to do it. Write the configuration and then look at it that way. I'm lazy. What's the highest energy level? 10 is right here. What period's it in? That's the highest energy level. I can look here and say 5. Let's start to show it. 5. You can do it that way, or you can do it that way. Either one works the same way. Okay? What element has a half-filled P sublevel? Did I say in period 4 in your paper? Okay. So in period 4, half-filled P sublevel. So, periodic table. Fourth period, so this is period 4, right? We said this is P sublevel again, so this is like the opening question. Who would be half-filled in P? All right? P1, P2, P3, P4, P5, P6. So who's half-filled? So arsenic. P3 is arsenic. All right, the orbital notation for oxygen Should be an easy one. All the rest of your space quizzes I ain't too sure. Yep, 1F, 2F, and then 2P has 3 lines. 1, 2, 3, and then down. And then goes 8 electrons. Same as order. You know how much I like my picture taken.
I know.
Thank y'all. It's my taking a minute. All right, so nickel has, what do we got? 1S2, 2S2, 2P6, 3S2, 3P6, 4S2, and 3D8 ought to give me 28, right? All right, and what do we have after that? A dot diagram for GE. 2, 1, and 1. And then the last 2 for homework were osmium. See if I can get them up here. Osmium has shorthand, XE, 6S2, 5D, we'll have 6, and 4F, 14. And then the last one was ND, XE, 6S2, 5D, 1, and 4F, how many? Thank you. Yes, if you have the 4F and the 5D switches, A-okay. Yes, ma'am. Why did I what? Oh, because you're using the atomic mass. You always use the atomic number. Okay? Anytime you do anything with electron configurations, you're always using the atomic number, never the mass. The mass is the protons and the neutrons. We never use the neutrons. Okay? Anybody else? Question on the homework. Particularly this part, given the difficulty we had on the quiz yesterday. All the way back to, you know, quantum numbers, quantum theory, dual wave particle, photoelectric effects, all of that. All of that. No, there's not a lot of that on there, but there's some. No, we do not.
What if we never did test correction? Can we go on this test?
No, because the next test you will want test correction.
Wait, what is it?
Bonding in the periodic table. It's
Man, that's what we need.
historically, this one is much higher scoring than this next one.
Wow.
I'm just telling you, historically, even though y'all are all moaning right now, historically, this one is much higher scoring. Unless y'all just are not the average class, this one is much higher scoring than the next one is. Even though y'all are all moaning, I would almost guarantee that y'all will do much better on this than you think you're going to. So stop complaining and let's keep moving, and I think you'll be pleasantly surprised.
What am I numbers?
Huh?
Why are you writing about
If I tell you that what Daisy would say, you'll laugh.
your prophet?
I am.
Yes.
Yes. Yes. No, it's not supposed to spell anything.
Oh, yeah, I thought.
No, it does not spell anything, so stop worrying about that.
Oh.
All right. All right. So let's finish what we were doing yesterday, because we need to finish that for today. Otherwise, this makes no sense. All right, so yesterday, you don't need to write group 1. We already did this yesterday. I'm just refreshing, hoping to catch Alexa up a little bit. Now, in group 1 yesterday, we said everybody in group 1 had 1 electron in the outer shell, right? So, when you have 1 electron in the outer shell, we drew a Bohr diagram that essentially had 1 electron out here on the outer shell. And we said, in order to get to 8, because everybody wants 8 electrons in their outer shell, we said we talked about how and why when we got to bonding next week. All right, so I need the exercise for this afternoon. So, that's going to help me a whole lot. So, when we get to bonding and we talk about this, we'll understand that every atom wants 8 electrons. So, what's the easiest way for this element or atom to get to 8 electrons? All right, so what would be easier for it? To lose 1 electron or gain 7 more electrons? What would be the easiest thing for it to do? Lose 1, okay? I liken them to adults or teenagers. people are not going to run around and gain 7 electrons when they can just lose 1. Now, if we lose 1 electron, what is its oxidation number going to be? Well, we were using sodium yesterday, so it had 11 protons, and if we lost an electron, we had 11 electrons, we lost 1, we were down to 10 electrons. So when we added this together, we wound up with a charge of +1 for our oxidation number. And so we talked about why we had a positive oxidation number. What do we have more of? More protons or more electrons? More protons. All right, so the oxidation number is positive because there are more protons when electrons are lost. Now, that part right there, I probably did not write down yesterday. I know we talked about it, but I probably didn't write it. So if you want to add that, feel free. So, anytime you lose, what I put in brackets? I probably didn't write that yesterday. Now, anytime you lose electrons, anytime, you are always going to have more protons. So, if you have more protons, your oxidation number is always going to be what? Positive. As long as you keep that straight in your head, you should be okay with the sign. Danielle. That's right. So they're not going to do what? Exactly. Okay? It's just a basic trend that's on the periodic table. We could use the periodic table to predict various things about the element. So you can look up at the periodic table and say, oh, aluminum is in group 13. So if it's in group 13, how many outer shell electrons does it have to have because it's in group 13?
So I guess the aluminum is whatever element you have, like the atomic number of whatever element you have.
Okay, and this is sodium, and it's in group 1. So if you look at the periodic table, and because it's in group 1, how many outer shell electrons does it have to have without you ever drawing? It's in group 1. How many outer shell electrons does it have to have? 1. So how many dots would it have in this dot diagram without you ever having to draw? So if I ask you to draw a dot diagram the lazy man's way, you would tell me the dot diagram is this. You would tell me potassium is in group 1. What's this dot diagram without ever drawing? Because it's got 1 electron in its outer shell. Okay? Now, you need to write a formula for the next equation that we write. You can't have your oxidation sheet. It's in group 1. What's its oxidation number? Sodium has an oxidation number of +1. Next time you have to look up the oxidation number for sodium, but you can't look it up on your oxidation sheet. Okay? That's what the periodic table is going to do for you. That's how we're trying to tie that in. Does that help at all? Okay. That's where we're trying to go with this. Now, group 2, same concept. Group 2 has how many electrons in its outer shell? There's 2 electrons in the outer shell. So, if it has 2 electrons in the outer shell, again, how would it go about getting to the magic number of 8? It can lose 2, or it can do what? Now, what did we say would be easier yesterday? The less. So lose 2 would be much easier than gaining 6. So if we lose 2, again, what do we have more of? Do we have more protons or do we have more electrons? We have more protons because we lost electrons. So there are more protons, 2 less electrons. So what does that mean about our charge? Are we going to be positive or are we going to be negative? So we're going to have an oxidation number of +2. That's what we did yesterday. Okay, is everybody with me on what we talked about yesterday? Hopefully so that you would identify the charges that went with everything. Yes. Yeah. Yes, day 60 is approaching rapidly. We're on day 46. And you will have to do it in the gas laws, which will be after day 60. Yep.
Yeah, we don't.
No parties. All right, so group 13 is where we were yesterday, right? So, I wrote aluminum, if I'm not mistaken. And we had neon, probably 3s2, 3p1. And we said there are how many electrons in the outer shell? 3.
This is the first day we get back to.
Okay, cool. All right, so, yeah. It's like the 27th, 26th, somewhere around there. It's not very far away. You have a 4-day week next week, a full week, and then a 2-day week. It's almost here. November's a fabulous month. We have short weeks, full week, short week. And then like 3 weeks in December, and then we have a really short Christmas break. I'm still pissy about. January the 3rd. Because the 1st is a Monday, so y'all have Tuesday off. All right. Moving on.
Yeah, we don't have like about a week off.
Now, we used to come back on the 2nd, so we thankfully y'all get the 3rd. Now, don't worry about the old calendar. It was really good on the old calendar. It's not on this calendar. Stop worrying about it. Now, moving on. So we have 3 electrons in the outer shell. How can we go about getting to an octet? Okay, you can either lose 3 electrons or you can gain 5 electrons. Which one requires the least amount of energy on the atom? Losing 3. So if we lose 3, what's the oxidation number going to be? That's right. The oxidation number will be +3. Okay? Now, what's going to happen, though, when we get to the next group and we hit group 14, which is where we need to pick up from yesterday? What happens when we get here? That's right. So if we do silicon,
all because it's 4 electrons that you can gain.
there you go. So now it's like being at the halfway point. Now we have 4 electrons in the outer shell. So now you would say we could lose 4 or gain 4. So who's to say what's easier, to lose 4 or to gain 4? How do we know? That's right. It would depend on the element you're forming the bond with. Yes. Okay. So sometimes you might choose, well, the element might choose to be the atom that donates the electrons and becomes the negative element. And sometimes it might be the element that chooses to give away the electrons and it becomes the positive element. So, given it can choose to do either or, its oxidation number, positive or negative 4. Well, it depends, and that's got to do with other factors. That's well beyond where you get today. Well beyond. Okay? Okay.
You know, like, when we see something that we wrote in notes, and it makes sense.
I'm so glad it's up. All right, so we talk group 15. All right, so group 15. So group 15 has how many outer shell electrons? Without writing the configuration this time. It has 3. How many electrons does it have? Y'all listen to the question. This is why y'all messed up the quiz today. You in particular over there, what group number is argon? And you wrote noble gas. I said, how many outer shell electrons? It has 5 electrons in the outer shell. I was talking to Nate. So y'all pay attention on the test. Don't do that stupid stuff.
No, I like read that question way too fast.
Yeah, me too.
Slow down.
I was so happy.
All right, so there are 5 electrons in the outer shell. So, how do we go about getting an octet? Okay, you can lose how many, or you can gain 3. Now, this is the first time that gaining has fewer electrons. So which one would require the least amount of energy? There you go. So we're going to gain this time. So this time, let's just say we pick phosphorus. Okay? Just to illustrate. Okay, phosphorus has 15 electrons. If I gain 3, I would have 18 electrons and 15 protons. So I would wind up with what for an oxidation number? -3. Okay, so when you gain electrons, there are more electrons and fewer protons, which equals a negative oxidation number. Okay? So anytime you gain electrons, you're going to have more electrons and fewer protons. So you're always going to have a negative oxidation number. Does that make sense?
That's why something negative is
Exactly. Exactly. Yes. What's that number? Because 5 plus 3 equals what? And all atoms want how many electrons? Okay, the goal of all elements and atoms is to have 8. Yes, this is what we'll talk about when we talk about bonding in about a week. Okay, everybody wants it. You might want to go to the military, get married, have kids, whatever your personal goals are. Elements or atoms' goals are very simple. You want the electrons. Yes, they do. Some of you might be conflicted about what you want. They're not conflicted. All right, so group 16. Group 16 has how many outer shell electrons? Okay, so there's 6 electrons in the outer shell. So, how can it go about getting to the magic number of 8? What are the options? It can lose all 6, or it can gain 2. What would be easier for it to do? Gain 2. So if it gains 2, what's its oxidation number? Gain electrons.
Oh, it'll be negative 2.
That's right. It'll be -2. Because you gain, it's negative.
however many they use or gain the oxidation.
Ding, ding, ding.
Yeah.
Exactly. Positive, because you have more protons. Oops, too far. The oxidation number is positive because you have more protons when the electrons are lost. This is what? All right. Not going. No. 70 degrees that. I'm ready for it.
Yeah.
How many do it?
I need a white Christmas.
Anyway,
Let's see how.
the La Nina year. Y'all ain't got much hope. All right. So group 17 has how many outer shell electrons? 7 electrons in the outer shell. All right, so there's 7 electrons in the outer shell. What are we looking at?
Negative 5. Wait, what? Negative.
Gain 1.
Okay, gain 1 or lose. Which one would be easier? That's right. We're not going to lose 7 if we're only 1 away from having 8. Okay, so what's the oxidation number going to be? Got it. So the oxidation number is going to be -1. So, to bring this together, catch up with me for group 18. What's going to happen then when we get to group 18?
It's gonna be like, kind of like it was in, well, it's like a,
That's right.
doesn't fuck around with it.
All right, everybody caught up? All right, so group 18 has 8 electrons in the outer shell.
Ow.
Okay, so it will not gain or lose. It already has 8. It doesn't want to gain or lose any. It's happy. Okay? So its oxidation number is what? 0. It's not going to form a bond with anybody. Hold on. So what? From it will have an oxidation number of 0. The only thing that's different about it is it does not have an octet because helium only has 2 electrons. All the rest, argon, neon, argon, krypton, XE, what else we got down there? Did I miss one? Argon, krypton, neon, and xenon, radon. Those all have 8 electrons. The only reason this one doesn't is it only has one S2, but it's considered a noble gas because it has a full outer shell. So a lot of times instead of calling them octets, we'll refer to these as being full outer shell. So that's the only way that helium is considered different, is that it doesn't have an octet, but it is just as stable as all the other noble gases. It doesn't have 8 because it doesn't have 2 rings as an S and a 2 together. It only has 2 electrons total in its outer shell. It's still a full outer shell. It's still a noble gas. It still has a reaction to anybody. It still has all the same properties as the other noble gas.
Why is that? Like, this one's never
Oh, because when that one was made, that one did not have all of the same elements officially made. That one's several years older than that one. And if I got a newer one printed, these that still say, for example, this one says UUT, UUT, UUS, and UUO. Those 4 have also been officially made. So a newer one would have names on all those now. Yeah, but they're expensive. The sure not going to buy me a new one. Plus, that one was given to me by a book dealer several years ago. That's really cool.
Oh, no, I like the one you have.
The one that you have printed now is the one off the state website. So until the state gives me a new one, I'm giving you the same one that you use. Now, could I get a more modern one off a different website? Sure. But I'm giving you the same one you're going to see on the final website.
What's the kid office?
Well, it's not bad.
I like if there's meaning in them, it's still like in the front way or something.
Yeah.
So everything, just so like after that.
Those were just officially adopted last Tuesday.
Oh,
I mean, those were not, it's not like those were, this periodic table was just purchased when this room was remodeled. This periodic table is not outdated like 20 years. That is a brand new periodic table. That one is probably 5 or 6 years old. Now, the one that they're giving you, let me see the green one. That one has got a little age on it. Because they could really update this one at this point. This one is probably, yes, 2011. They could update this.
I was thinking like if they wanted to like updated.
Oh yeah, the state could update theirs at any point in time. They just don't. Yeah, but that periodic table was brought 2 years ago. Which is why there's only 4 elements that are missing. But they just named those within the last year.
And the question that you find, if you have to use one.
Yeah, sorry.
They're still kind of curious. Those elements have been projected to be discovered since I've been teaching. They have always done it.
So does the, why are some of the
They have a long process to go through to become legitimate elements, where they have to be tested, reproduced, and go through committee after committee after committee before they officially get made. And the last four finally did that last, December, January. Spring, even spring.
So what's the difference between the ones that are like filled in and the ones that are not?
Has to do with their flavor. The ones that are, not built in, best guess is their, lab chicken. Made in the lab. No, only 90 for natural return. Yeah, they all exist, but they're not all man-made. I mean, not all natural returns, some of them are man-made. All right. What? Hurry up, I need to move it. Because there's one other piece we gotta do with this. Most of them are radioactive isotopes that come from other radioactive isotopes. Yes. All right. Now, you gotta use your art skills a little bit here. It does not have to be stellar. Basically draw a rectangle. Nope. Yep. Big enough you can write these blocks. Alright. So, in these, we're going to put a couple things in here. We've got to talk about reactivity just a little bit. Wait, come on. I'm going to wait on you. Now, when we talk about reactivity of the elements, it's easier to do that if we summarize a little bit in the periodic table. So, we know the outer shell electrons at this point are 1 electron, 2, 3, 4, 5, 6, 7, and 8, correct? Now, if I ask you what's going to happen, you can tell me that group 1 is going to do what with that 1 electron? What? What the heck have we talked about for the last 2 days? What's it actually going to do then? Just tell me what it's really going to do. Go lose 1. Here, let me pick another color instead of red. Pick something. Alright, it's going to lose 1 electron. What's group 2 going to do? Okay. Group 13 going to do? Group 14 going to do? Alright. Group 15 going to do? And 16? And 17? And group 18? Alright, since we're summarizing, I'll go ahead and do the oxidation number, but it doesn't really go with what we're doing at the moment. So what's the oxidation number for group 1? And group 2? And group 13? Alright, group 14? And group 15? Good. Now, the part that I want to do is reactivity. Which groups on the periodic table are the most reactive groups? Group 1, why? Okay. I need a reason. Is group 1 is one of the 2 most reactive, but why? Okay, now the reason.
Because we don't cross numbers, it never changes.
I said, which groups are the most reactive groups on the periodic table and why?
Most common element.
You have one of the right answers. Group 1 is one of the most reactive groups on the periodic table. But I'm asking for why, and that's where we're struggling.
But they all combine with oxygen.
No. Most reactive metal. Alright. I'm going to tell you why.
Oh, because they got carbon in it.
One electron away from an octet.
Oh.
Okay? So, based on that, who else is the most reactive group on the periodic table?
17.
Alright. Group 17 are the most reactive non-metal. Alright, group 17 are the most reactive non-metals. Again, they're one electron away from 8. Those are the hoes on the periodic table. I don't offend anybody with this stuff. Group 1 will give it away to anyone who will take it. Alright. And group 17 will take it from anyone who is willing to give it to them. Okay? Everybody understand?
Yeah.
Okay. Not picky. No moral values going on in group 1 or group 17. Okay? What? Well, group 1 and group 17, they're in the shame category. No moral values going on in group 1 and group 17 at all. Non-metal. Now, group 18 is the most non-reactive.
Oh, because they already have an electron.
They already have 8.
These are the loyal.
These are the loyal people. These are your unmarried virgins in the crowd. Right? They never do anything. Never will. Okay?
It's like
They're the nuns. They believe in abstinence. They're never going to do anything. Okay? I don't care. Write it down. If you'll remember it, go for it. Now, as long as y'all remember it. Now, if these are the most reactive, where are the next most reactive going to fall? 2 and 16. Now, remember, and that's a common mistake. You see how Queen said 2 and 6? If I refer to these on the period or on the test, when I talk about group numbers, am I going to say 2 and 6, or am I going to say 16? 16. Now, to throw y'all off, what other group will I also have listed as a foil answer? 6. Remember, group 6 will be over here somewhere in the transition element. So don't let me get you with that, okay? Group 16 is the one that has 6 electrons that's over here besides group 17. Okay? It is 65 multiple choice questions. Okay. Now, find the back side of your homework from last night. Let's talk about it real quick. I did. Yes. Yes, ma'am. Okay. All right, so question 1. Which of those letters is an alkaline metal? C is an alkaline metal. Why can't it be I? I is not a metal, that's in hydrogen spot. It cannot be I. An alkaline earth metal would be F. Now, this is why I wanted to wait on this. Now you can tell me who the inactive gas is. Who is the inactive gas if you did not know? A is not an inactive gas. An active non-metal, you should be able to tell me now. H. You did not know that. The active non-metal is a halogen. Active and reactive mean the same thing, by the way. Now, semi-metal. Active and reactive mean the same thing. All right? And I'm not, where was I? Semi-metal. B, that would be your metalloid. Semi-metal is metalloid. an inner transition metal, we did not name that specifically, I don't think, but an inner transition metal comes from the inside of the transition metal. So this down here is an inner transition metal because it came from inside the transition metal. You know, they were cut out of that little spot right here, moved down.
Okay.
That's what they mean by inner transition. They were inside the transition and they got moved out and moved to the bottom. So that would be D. All right, the most common oxidation number is -2, so that would be G. The metal with more than one oxidation state would be E, because it has to be a transition element. Metal with an oxidation number +3 is J, and it has an oxidation number of +1 and -1, which is I. I can be -1. We will probably not do anything where it's a -1. All right, let's talk about some application questions. Now, a lot of this you're going to take home for homework tonight, but I do want to at least try number 44 before you leave, so you have some idea of what you're doing tonight.
What's today, Wednesday?
Today's Wednesday.
I want to accept it. I'm ready. We're ready.
Okay. Let's look at question number 44. Jordan, that's one of your best questions. All right, look at 44. All right, in question 44, if you look at that one real quick. Oops, want to do that. I think I had a periodic table on that up front. Oops, there it was right there. Oh, at the top. All right. In the first line of the question, you see how it says the second period element? Your answer choices have to come from there, okay? I'm not going to give you very long. Read through them and see what you think.
Do each of them have a different answer?
No, some of them could have the same answer more than once. Yeah, simple is fine.
Oh my God.
I'll take it.
For what? No.
Except for the 10th graders. 10th graders take the free ABCs.
Are we gonna go to second then?
Oh, we don't worry.
Yeah, you will go second with the head.
I'll be up here.
Wait. Emma, I take it.
Yeah.
Yeah. How come I never knew about this?
You have a meeting at some point. We're thinking about it. Maybe I can try it. I'm going to tell you.
I'm gonna have to leave.
Who else outside Jordan's 10th grade? So, I only have 2. Yeah.
But if I go like.
I have no idea. They're not going to transfer. I'm sure they'll tell you about it. Like a PSA. It's not, it's easy. The final part is graph reading 101.
No, Eagle is good. I started with Eagle.
Who said that? 101 or breakfast lunch? Alright, let's look at some of what they have there, because I'm not gonna sit here while y'all argue about the 3 Alright, but thank you for only having 2 sophomores in here because y'all spared me from having to get. Alright, question 44. So, what does it mean when it says a total of 4 electrons? What are they asking you to find? The atomic number. So if you didn't know that, alright, right, total.
This is just a reminder to our students that we do not have grab and go today due to the college fair. Please do not go to grab and go to class. Teachers, please do not give tickets out for grab and go.
You could have said that 5 minutes ago. Alright. So, who would have a total of 4 electrons in the second period? BE. Guys, you're not going to have to do the bottom if you don't pay attention. So BE, your test, probably out of 65, 30 of the questions are going to look like these. Just saying. All right, contains a total of 5 electrons in the highest main energy level. What does it mean to say highest main energy level? What's that? Got to stay in the second energy level. Highest main energy level is the same as saying outer shell. Okay? So you're looking for 5 electrons in the outer shell. So you're looking for 5 electrons in the outer shell. So 1, 2, 3, 4, 5, which means you have nitrogen. Okay? So if you don't know that, write it down.
I don't know if it's a matter of counting or like knowing.
That's why I'm telling you how to translate those questions. So where it said total electrons, total is telling you atomic number. Where it says highest main energy level, they're telling you outer shell. It's just another way to word it. Okay? Now, the next one says a total of 2 electrons in the P sublevel. So P sublevel, 2 electrons means P1, P2, which would be what? Carbon. Now, for homework tonight, I want you to finish 44 and 45. Okay? Everybody got it? We will spend no more than 45 minutes tomorrow total on review. You will be told. You've got a meeting sometime this week, 4th period in the auditorium, but I don't remember what day. Because it doesn't affect me. Yeah. Yeah, I'll be here till about 4:15 tomorrow.
Wait, come on. I'll wait here in my heart.
No, hold on. See if I can do that real quick. Hello, my dear.